Now let's continue with the previous lecture, and this is 1.3 Probability Axioms. Now, before going to discuss the axiom, to model the probability we assign probability P of A to every event A in the sample space. Now, definition here 1.5 Axioms of Probability. First one, axiom 1 says that for any event A, probability of A is greater than or equal to 0. Axiom 2 says probability of sample space is equal to 1. And last axiom, axiom 3 says that for any countable collection of events A1, A2 and so on of mutually exclusive events probability of A1 union A2 union so on is equal to their sum of probabilities P1 A2 plus so on. So these three main axioms that help us to solve the probability problem. So first one is that probability is a non-negative number. Second one is that probability of sample space is 1. Third is if you have collection of mutually exclusive events, then their probability is always sum of individual probabilities. So these axioms are very important to solve the probability problems. Based on these axioms, we do have some theorems here. So the first theorem based on these axioms that help us to solve the probability problem is theorem 1.3. Now theorem 1.3 says that for mutually exclusive events A1 and A2, probability of A1 union A2 is actually equal to probability of A1 plus probability of A2. So this theorem actually uses the axiom 3 of the probability. And there's another theorem 1.4 says that if A is A equal to A1 union A2 union so on union AM and AI intersection AJ equal to null set, means that the odd events A1 up to AM are mutually exclusive for I is not equal to j, then probability of event A is actually easily written as a summation I is from 1 to m probability of A of I. So again this is also same and this theorem is also using the axiom 3 of the probability. Now theorem 1.5. Now 1.5 says that the probability of an event B, and B event has some outcomes, that is S1, S2 up to so on Sm. So there are m outcomes, is the sum of the probability of the outcome contained in the event, that is probability of B is equal to summation I is from 1 to m probability of S of I. So these three theorems actually help us to solve the probability problems, and these three are based on the axiom 3 of the probability theory. Now there are some notations that we need to know when we solving probabilities. So for example, normally we can say probability of A intersection B, we can write as probability of A comma B, or simply as probability AB. These are all the same notations. Sometimes we don't write like this, that probability of I. We can write it as probability of S of I. So these are the same notations. Okay, the another important terms is used as equally likely outcomes. Equally likely means that if no outcome in the experiment is any more likely than other. So, in simple words, equally likely means that the occurrence of outcomes, the chances of occurrence are equal for all the outcomes. For example, if we have a sample space, say S, has some outcomes that are S1, S2 up to Sn. So, there are n outcomes. So, if they are equally likely, so this implies that the probability of any outcome is equal to 1 divided by n. So, this is actually represented as a theorem 1.6, and theorem 1.6 that for an experiment with sample space S is equal to S1, S2 up to Sn as outcomes, in which each outcome Si is equally likely, then probability of Si is equal to 1 by n, where I is between 1 and n. Okay, let's do some example on this to get this concept further. So, we have example 1.13 here. This example says that we roll 6-sided die. So, this is the first thing, in which each phase are equally likely. What is the probability of each outcome? Now, if we roll a 6-sided die, so question is, what is the probability of each outcome? This is the first question. Next question is, find the probability, find the probability of the following events. What are these events? So, let us say first event says that event is roll 4 or higher. Now, say event B as roll an even number. Event C is roll the square of an integer. Now, first of all, so how we solve this probability problem? The first step is to write the sample space. Now, there are 6 sides, so we have 1, 2, 4 and 5 and 6. These are the possible outcomes in the sample space. Now, probability of each outcome, for first one, probability of each outcome, say I is equal to, because this is equally likely, is equal to 1 by 6, where I is between 1 and 6. Okay. Now, This is the first one. Then next is probability of event of A. Now, if to calculate the probability of A, probability of B, and probability of C, it's better to write the events then try to answer this question. Now, let us see what is event A. Now, event A is roll 4 or higher. So, we have 4, 5 and 6. Event B is roll an even. So, in case of even we have 2, 4 and 6, and last one is event C, that is square of an integer. So, we have 1 and 4. So, now after knowing this event, so it is very easy to calculate the probability of A. Now, probability of A, if we use the theorem that says that we have to calculate the probability of 4 plus probability of 5 and plus probability of 6. Now, each probability is equally likely. So, in that case probability of A is equal to 1 by 6 plus 1 by 6 plus 1 by 6. Now, if I solve it, it becomes 3 by 6, that is 1 by 2. Similarly, probability of B is probability of 2 plus probability of 4 plus probability of 6. Now, again this is also 1 by 2. And last one, probability of C, that is equal to probability of 1 plus probability of 4. So, it becomes 2 by 6, that is 1 by 3. So, this is the way you can easily solve the probability related problems. Now, I stop here.